Hello and good morning to everyone. So our today's Leetcode question is 3666. That is minimum operations to equalize binary strings. So basically it is a hard question. So we have to be patient and we have to watch the video up to the last to understand all the different approaches that we will be following. So in this question we are given a binary string s and an integer k, and in one operation what we have to do is we have to choose exactly k different indexes and flip 0 to 1 and 1 to 0 on those indexes, and we have to return the minimum number of operations in which we can make all the characters in the string equal to 1, and if it is not possible then we have to return -1. Let's see some examples to understand the problem statement more clearly. So the first example is we are given 110 and k is equal to 1. That means we can choose one index and flip 0 to 1 and 1 to 0. So what we'll do is we'll select this index and convert 0 to 1. Now we'll get this string. So all the characters are 1. So our requirement is fulfilled in only one operations, right? Let's see the next example. So we have 0101 and k is equal to 3. Now we have to choose three indexes and we have to flip the bits. So what we do is first of all we'll be selecting this bit and this bit. So what we get? We get 1 0 0 and 0, right? Now we'll be selecting these three bits. So 1 1 1 and so total operations are 2. So we get all ones in two operations. Next, the third example is 101 and our k is equal to 2. 101 and k is equal to 2. So there is no way by which we can select any two indexes and uh, flip the bits and we get all ones. So there is no operation, so the output is -1. So if you'll see the constraints, the string length can be up to 10 ki power 5 and k can be also up to 10 ki power 5, right? S is also up to 10 ki power 5 and k is also up to 10 ki power 5. So what can be the brute force approach for this problem? So brute force approach is like for from a string we'll be trying all subsets of size k, right? And then we flip those subsets, and then we'll make a graph of those all the possible subsets, and then we'll be applying BFS until we get all ones. So if you'll see the what will be the number of states, the number of states can be up to 2 ki power n. So with these constraints, that is the string length up to 10 ki power 5, it won't be possible for this approach to work. N should be less than equal to 20, right? So for these constraints this brute force approach is will not work. So let's see how can we optimize this brute force or like. So the first approach is using BFS on count of zeros, right? So as we know what we want the number of zeros in the string to be 0, right? So what we do is we'll make a graph in which state our node will be the number of zeros, and what will be the as is will be the zeros among z, right? What we do is, so suppose we have z number of zeros is z. So what we do is we'll choose x zeros from this z. Then how many ones we'll be selecting? Total we have to flip k bits. So we have select x as zeros, then k minus x will be ones, right? This will be select. So these will be the as is. So now earlier what we do is we randomly selecting k bits. Now what we do is we select x zeros and k minus x ones, right? And what will be the feasible x condition? What will be the condition for the x? So the number of, so first condition is x should be less than or equal to k, because at max we can flip k bits, right? This is what we are given. So this is the first condition. The second condition is number of zeros that we are flipping, that is x, it should be less than equal to total number of zeros present in the string. That is, we are assuming that the total number of zeros is z, so x should be less than equal to z. If total number of zeros is z, then total number of ones is n minus z, right? So the second is k minus x, that is the number of ones that we are flipping, should also less than equal to n minus z. So these are the three conditions for the feasible x, right? Let's see ahead it. So let's suppose n is the total length of the string, z is the number of zeros in the string. So any operation flip k indexes, right? So only the count of zeros matters for us, not like where the zeros are present. So for us only count matters. So what we do is, if we flip x zeros and k minus x ones, then zeros will become, what will the new zeros, right? So suppose currently we have z zeros and we have flipped x, right? And we have also flipped k minus x ones. So these ones will become zeros and these zeros will become 1. So our new number of zeros is current 0 minus this x plus k minus x, right? I hope you get this equation. This is our current total number of 0. Then x is the number of zeros that we have flipped, thus those zeros which are converted to 1, and this is those ones which are converted to 0. So our new z will be the number of z that we have now is z, current z plus k minus 2x, right? So from z to new z we can move using feasible x values. Now what we do is we'll try all the possible values of x to move from a current state z to new state, right? And then what we do is we run BFS, right, until z will become 0, that is the number of zeros will become 0. So if you'll see the complexity of this approach, so total states will be n plus 1, and for each state what we are doing is we are trying all x from 0 to k, right? So it will take big of k time, and so total states is n, and each state is taking k time, so time complexity is n into k, right? So first see the code of this. So in the code of this is like, for every character we are counting the number of zeros, right? First we have count the number of zeros at z0. Then if number of zeros is 0, then means all characters are ones, means we get our answer. In that case we will return 0. Then we have taken a vector dist, it will store the number of steps to reach to a state, and we are using a queue to simulate BFS. And distance of this number of initial zeros is 0, because the number of zeros that we have initially is present, so there is no operation required for that, and then we'll be pushing this number of zeros in the queue. Now next what we'll do is we'll use a while loop until our queue do not becomes empty. We take the uh, front element from the queue, and that is z. So z is the number of zeros in this state, right? Number of zeros in this current state, right? So we'll be finding the number of steps that we have taken to reach this state, that will be given by dist of this state. So if suppose number of zeros is 0, then we'll be returning the steps, like how many steps we have taken to reach this state where our number of zeros is equal to 0. So suppose this condition is not satisfied, so we'll be moving to next step. Then we'll be finding the number of ones. So if suppose our string length is 5 and z is equal to 2, so number of ones will be 5 minus 2, that is 3. So we'll be finding from here. Now next what we do is we have flipped x zeros, right? We have flipped x zeros we have flipped, right? So what will be the minimum value for x? As we have already discussed, x should be less than equal to k this condition should be satisfied, x should be less than equal to number of zeros, and k minus x should be less than equal to number of ones, right? See, these conditions I am talking about, these three condition, right? So k minus x should be less than equal to n minus z. So if we solve these three conditions, we get x minimum can be max, will be maximum of 0 or k minus 1s. See, this is number of ones, right? This is number of ones. So if we solve it, x minus number of ones is less than or equal to x. So this value is less than or equal to x. That means x is, so this can be the maximum value, right? So x minimum will be this value, and then x maximum we can find from minimum value of k. Either we can remove k elements, or suppose z is less than k, then we can remove this number of zero elements. That is the maximum zeros that we can flip. So we get minimum and maximum. Now from minimum and maximum we will be checking each value. We'll take each x and find the next state. So already we have discussed the next state is equal to z plus k minus 2 into x, right? This we have already discussed above. So if the new state has number of zeros less than 0 or greater than n, so both these conditions are false, so we'll be ignoring this x value, right? The other thing is like distance of this current state is not equal to -1. That means we have already reached this state. This state is already reached, so we won't be exploring it again, right? Else what we'll do is we'll increase the distance of this state by 1, right, and push this state into the queue. So this way we'll be exploring all the states, and at the end we'll be returning -1. If none of the answer is possible, we'll be returning -1. So but the thing is that here when I executed this code, it has given me time limit exceed, because the time complexity is big of n into k, where n it can be equal to k, and it can be equal to up to 10 ki power 5, so it won't be possible. So the above approach is giving us TLE, so we have to somehow optimize this approach. So what we do is, instead of using the normal BFS, we'll be using optimized BFS. So in the approach, above approach, you have noticed that we have a loop of x from x minimum to x maximum, that is making our time complexities of n into k. So if somehow we remove this loop, then our time complexity will be big of n and our work will be done. So now let's see how we can do that. So suppose in the above code we have find x minimum and x maximum. So suppose c1 is equal to x minimum and c2 is equal to x maximum. Then and also we have find a new z is equal to z plus k minus 2x. So these all things we have discussed in the above approach. So if you are directly arrive to this approach, make sure to see approach 1, else you will get stuck. Now suppose if I increase x by 1, if I increase this x by 1, then our z will decrease by 2 steps, right? 2 values. So what are the reachable new z values are? Suppose this is our minimum x minimum, right? C1 is our x minimum and C2 are x maximum. So if we have to find minimum z, then we have to remove subtract this maximum value, right? If we subtract maximum value, then z will be minimum, and if we want to find z to be maximum, then we have to subtract this. So our range will be from z plus k minus 2c2. This is will be the lower bound and this will be the upper bound, or we can say right bound, right? So L is z plus k minus 2 into c2. So c2 is the maximum x. So if we are subtracting maximum x, then we get the minimum z, that smallest value of new z when x is the maximum, and this is the largest value of new z when x is minimum, that is c1 and c1. So from this we will be finding all reachable next states. So all reachable next states for z are numbers between L to R, and you know what is the value of L and what is the value of R. But the thing is that in L to R also you have seen that z is equal to z plus k minus 2 into x. So for every second number in range L to R, like suppose L, then L plus 2, then L plus 4, this way, right? So all the numbers have the same parity. Suppose let's see an example. If L is equal to 3 and R is equal to 11, then the states that are reachable from the current state are with Z equal to 3, 5, 7, 9 and 11. If you notice, all are odd. And next is if L is equal to 4 and R is equal to 11, then the reachable states are 4, 6, 8 and 10. These all are even. So if you see, if L is even, then all the reachable states are also even numbers, and if L is odd, then all the reachable states are also odd numbers. That means the parity of the reachable states is equal to the parity of L, right? Parity means odd or even, parity bit, right? Then what we do is, once we get our reachable states, then we check which of these reachable states are present in unvisited number, right? Which of these states are unvisited, then what we do is we mark them as visited and push them to the BFS queue, and also remove them from unvisited array. So let's see the code part. So in the code we are taking each character and counting the number of the number of zeros. So the count of number of zeros is z naught. So if count is 0, then we will directly return 0. Then we have taken a vector which we have already taken in the previous one. Then this unvisited by parity. So here size is 2. So either parity is 0 or parity is 1. So if the number reachable number is even, then parity is 0, and if it is odd, then parity is 1. Then for each state, so the number of zeros can be from 0 to n, right? N is the length of the string. So what are the possible number of zeros? It can be from 0 to n. So now what we do is we'll divide all the possible states into uh, two different parities. So 0, 2, 4 and so on. It will come in even parity. 1, 3, 5, all those numbers come in odd parity. So we are dividing all the possible number of zeros into different parities, right? And storing them in our unvisited vector by parity. Then we have taken a queue to simulate BFS, and we have pushed our initial count of zeros, that is z naught, into the queue, and the steps that we have taken is 0 to reach this state. And also we have marked unvisited parity of this z naught. Suppose if z naught is 15, so 15 mod 2 is 1, so unvisited parity of 1. So we have removed z naught from here because we have reached this state, so we are marking it reached or visited. Next what we do is, next then we are simulating our BFS using the queue. So we take the top element from the queue and then we check. So the top element will store the number of zeros. So the number of ones will be total characters minus number of zeros. So we get number of ones. Now here x is the number of flipped bits, so we will find x minimum and x maximum, right? We find x minimum and x maximum, and we check condition if x minimum is greater than x maximum, so it should not be possible, so we'll be ignoring that case. And then we get x minimum and x maximum. Then from using x minimum and x maximum, we'll be finding z minimum and z maximum. As already you know, z is equal to z plus k minus 2x. So if we'll put here x maximum, then we get z minimum, and if we'll put x minimum, then we get our value of z maximum. So we find z minimum and z maximum. Then we check the parity of L. As I have already told you that all the reachable states, that the parity of all the reachable states is equal to the parity of L, right? So we'll be checking parity of L in the unvisited by parity, and storing all the unvisited uh, what we call states. We are taking all the unvisited states, and then we are checking whether these unvisited states are present between L to R, right? So all the unvisited in from all the unvisited state, will be taking the smallest unvisited state which is closer to L. So it can be either L or L plus 1 or L plus 3 or so on, right? So we'll be taking that using lower bound, and once we get that, we'll be mark that distance with distance z plus 1 and push that into the queue and move to the next iterator and mark it visited, right? And at the end what will be returning is, we'll be returning distance of 0. That is the state where number count of 0 is equal to 0. So the number of steps that we take to reach that state, so if it is equal to infinite, that means we haven't reached that state, so we'll be returning -1, else we will be returning the number of steps. So I hope I am able to explain you these two approaches. So after this we will be discussing a third approach which is even faster than these two approaches. In the third approach, what we are doing is we are searching on the answer. So let's see, we have like converted this question to a different question. So like what we are doing is we are asking ourselves, like, is it possible to finish this problem in exactly t operations? Like, can we make the string as all ones in t operation or not? So if yes, we can make it in t operation, then what we do is we'll try with some smaller value of t, and if not, we'll be trying with some bigger value of t, like kind of binary search type, right? And at the end what will be returning minimum value of t. So let's see. And also, what will be the total number of flips required? So what are the total operation? T is the number of total operation, and in one operation we are flipping k bits, right? It is asked to flip k bits. So what is the total flips? Total flips will be t into k. Now see, if we have suppose a character as 0, so if you have to make it 1, so either in one flip or 0 1, again 0, and then again 1, so 3 flips. So if our character is even, if our character is 0, then the number of time it must be flipped to make it 1 is odd, right? And if our character is 1, then it must be flipped even times to make it again 1, right? So keep these two statements in mind. That is, if our character is 0, then it must be flipped odd times, and if our character is 1, then it must be flipped even times, right, to make it 1. And the total flips of zeros and 1 should be equal to the total flip, that is t into k. Now sum of z odd numbers has parity z mod 2, right? Suppose if we add z different odd numbers, then we don't know either they will be even or they will be odd. So whatever result they has, that is Z mod 2. And sum of z even numbers is even only, because if we add different even numbers, at the end we'll getting a even number only. So in that case, if sum of z even numbers is even only, but we can't say for the odd numbers that if we add two odd numbers we will get odd. No, we can even get even number also. So that is parity we have to find in this case. So what is the total parity? So total parity, see, total flips is t into k, and t into k should be congruent to z modulo 2, where z is the number of zeros, right? So let's see, if k is even, if our k is even, then t into k will always be even, right? Then z must be even, that is the number of zeros initially should be even, else it is not possible to convert the answer. Let's see this example, 101 and k is equal to 2. So now our k is even but the number of zeros is odd, so it is not possible to convert this string to all ones in using 2 bit flips at one time, right? Next is if k is odd, right? If k is odd, then t must have same parity as z, like whatever parity z has, t also should have the same parity. Suppose here if k is equal to 3 and z is 1, right? So parity of, so t into k should be equal to t modulo 2, right? So these two conditions help us to remove half of the t values, right? Because we are simulating our t values only. So next, let's see, understand it even. So how many flips can zeros या one can absorb? So let's say f naught. F naught is the total flips assigned to zero position. So suppose we are given a string in which have several zero positions. So F naught is the sum of all the flips that those zero positions has, and F1 is the total flips assigned to the ones position, right? So F naught plus F1 should be equal to T into K, because as we have already know, T into K is the total number of flips. And let's see, for zeros we have discussed that for zeros the number of flips must be odd, else it won't be converted to 1. So for zeros it must be odd and it must be between 1 and t, right? And so minimum odd we can give to each zero is 1, right? So suppose we have 1 0, so if you have to convert it to 1, so minimum flip we required is 1. And we have, suppose z zeros, so what is the value of f naught minimum? It will be z only, right? And next is maximum odd we can give to each zero is largest odd value which is lesser than t. So suppose if t is odd, then the largest value will be t, else it will be t minus 1. So what is the value of f naught max? F naught max can be z into odd max, like it can be either t or either t minus 1, depending on if t is odd or t is even. So z f naught is like this value, z into odd max, where f naught is the total number of flips for 0 bits, right? So also parity of f naught should be equal congruent to z modulo 2, right? And for ones the number of flips must be even, and it also should be between 0 and t. And what is the maximum even number that we can get? It is also less than or equal to t. So if t is even, then the even maximum is t, else it will be t minus 1. And the what is the minimum flip that we have to give to 1 to make it
again 1. So if you want to flip it, it's still 1. So minimum is 0 and maximum is number of ones into even maximum value that we get, right? So since f1 is equal to t into k minus f naught, as we already discussed, number of flips of 0 plus number of flips of 1 is equal to t into k. So from here we get f naught, f1 is equal to t into k minus f naught. We get this equation. So this become a constraint on f naught. So what is a value of f1 that we get from above equation? That is f1 maximum can be O into even maximum, right? So let's see. So f naught maximum can be t into k and minimum it can be t into k minus flips of total flips of ones, right? Total flips of ones, or it can be, suppose if you won't flip any one, we only flip 0, then it can be into t into k. So this is one constraint for f naught. So f naught must satisfy both the capabilities. For zeros that is f naught should be z, if we flip only one time, else z into odd maximum, where z is the number of zeros, and one's capability is that if you flip if you won't flip any single time, then it will be t into k, else it will be t into k minus o into even maximum, like these two equations. So using these equation we'll be getting the left bound and the right bound of the possible z's, right? We'll be getting the left bound and right bound. So if we'll see the overall steps of this approach, then what we have to do is we'll be finding a t minimum, that is minimum number of operations we require to convert all bits to 1. And then for this t minimum we'll check whether it is feasible or not, right? So how we'll be checking? So what will be the total flips? So total flips will be t into k, right? And zeros need odd flips, so the number of zeros, that is z. So the total flips for zeros should be z mod 2, right? If the total flips for zeros is not equal to z mod 2, means it is not possible with this current t. We'll be ignoring that t. And then what we do is we'll be finding maximum flips per index, and after that what we'll do is find valid range for f naught, that is l and r, that we have seen above, like we will be using equations to find the value of l and r, and then we'll be finding feasibility check whether that is feasible or not. So for final feasibility check, there exists a value in the range l to r whose parity is equal to z, and if that value exists, then we get our t minimum, that is the minimum number of operations. Else what we do is, else we will move to the next t and do the same operations, and if there is not a single t, then we will be returning -1. So let's see the code of this approach. So first of all what we do is we'll store the count of zeros in z. So z is, if z is equal to 0, we will be returning 0. The second case is if parity of k and parity of z is not equal, that is, suppose if k is equal to n, if k is equal to n, then we check whether z is also equal to n, because we have to flip n bits at one time. So if z is not equal to n, then it is not possible to convert, so we'll be returning -1. So and if z is equal to n, then we'll be returning 1. And the second condition is if k modulo 2 is equal to 0, that is if k has even parity and z has odd parity, then we have to return -1, because t into k should be congruent to z mod 2. This is the condition that we have discussed. So if this condition fails, then it is not possible to make an answer, because if k is even, then t t into k, t into k will, this will be even, so this z should also be even, but here z is odd, then so it returns -1. After this we have this function. What this function will do, it will check whether is it feasible for a t value, for a t number of operations, can we convert the whole string in all ones. So this helper function will help us to check whether is it possible or not. So what we are doing in this function, we are first finding the total flips, that is t into k. We are find the total flips, and then we are checking the condition, if the parity total, so one ll is one only in long form. So we check the parity of this total flips, and if this parity is not equal to z, that is t dot k is not equal to z mod 2, that their parity is not equal, then we'll be returning false. If their parity are equal, then what we do is we'll be finding odd maximum and even maximum, right? That is the how many odd maximum steps we can take, how many even maximum flips we can take. And if odd maximum is less than 1, means odd maximum we are using for zeros. So if that is less than 1, means we can't flip 0, so we'll be returning false. Then we'll be finding the number of ones. The number of ones is equal to total length minus number of zeros. Then using that we'll be finding L and R, that is the lower bound and the upper bound of the Z. So if lower is greater than upper bound, this is also not possible, so it should also return false. And then we, what we do is we again check the parity of L, right? So we check the parity of L and we check the parity of Z. If their parity are equal, then we get our answer, right? We'll be returning either true or false. But if their parity is not equal, then we'll be checking for next L value, right? So this way we'll be check whether we can, is it possible for this t to convert all these what we call characters into ones, right? So see here, here what we are doing is we are taking the minimum t. So minimum t is equal to ceiling of z by k, right? So we take minimum t. So if this number of operation is less than 1, then we'll make it 1, right? Then we'll check for t is equal to 1. Also here what we are doing is we are checking parity of k. If k mod 2, if k is, sorry, odd, then t into k is also odd, right? If this is odd and t and z parity is not equal, then we will be moving to the next t, right? But if their parities are equal, then what we do is we'll check for t, we'll check for t plus 2, we'll check for t plus 4 until we get okay from this function, right? And at the end, and then if suppose for some t we get our answer, then we'll be returning that t. And if none of the t is possible, then we'll be returning -1. So this is a like complex problem. So if you don't get the solution, you should give it a try, try to understand it clearly. So if you like the solution, please make sure to like, share and subscribe. Thank you. That's it.